All right, welcome everyone. It's really a great pleasure to have Philippe Yuan to present the work of Archi-Union, his practice, with us this evening. At a time of increased polarization across all spheres, we always enjoy here in this auditorium the opportunity to hear and learn about ways to bring things together. Whether it is around the intersections of discourse and practice, the thinking across scales and disciplines of the built environment, the design of intersections between the pragmatic and the visionary, the hybridizing between the urban and the rural, between nature and culture, the digital and the analog, or whether it is simply about creating new relationships between drawing, making, and building to open up new modes of research and practice, which move beyond questions of criticality and engagement. All of those investigations are ones we seek here at the school, without ever finding simple or singular answers, but rather by looking at inspiring models and emerging practices. And so tonight, I'm especially excited to have Philippe here with us, since I believe his work through Archi-Union is uniquely contributing to moving beyond these kinds of false choices we often seem to be grappling with. Based out of his hometown of Shanghai and with a strong commitment to both research and to building in the world, Archi-Union is offering a new model of practice that is at once deeply embedded within the issues of China's rapid urbanization and technological development, while simultaneously resonating across the architectural sphere. Like many, I was first struck by Archi-Union's work at the recent Chicago Architectura Biennale, where their stunning in bamboo project was presented, one that Philippe recently described as, quote, rural area prefab industrialization in the era of digital humanities. Bringing together a strong commitment to local materials and building knowledge with computation and digital fabrication, the project weaves vernacular sensibility and traditional typology with cutting-edge technology, a certain contemporary formal fluidity, and programmatic flexibility. Built on the traces of two traditional courtyard houses, In Bamboo is a community center whose sole purpose, it seems, is to invite the rural community of Daoming, a Chinese metropolis of Chengdu, to think about its future through architecture. This thinking across and moving beyond, it extends with Archi-Union to the question of scale. The practice is as comfortable engaging with visionary master plans as it is designing exquisite installations. Their commitment to building allows them to bring together visionary aspirations with a keen, pragmatic sense of dealing with budgets and local construction methods, as well as expertise. Finally, Archi-Union's collaborative spirit, also a sign of our time, has rendered the practice one of the most compelling to emerge out of China in recent years. A committed academic, Philippe received his PhD from Tongji University, where he is currently part of the faculty, teaching but also coordinating the Digital Design Research Center and continuing to kind of practice through research and research as a form of practice. Philippe is also the co-founder of the Digital Architectural Design Association of the Architectural Society of China and is the organizer of Digital Future, Shanghai's joint summer school program, where Philippe has been strongly promoting digital design and fabrication already since 2010. His writings have appeared in a number of journals, including AD, Arquitectura Viva, Detail, and T+A, and his essay, Performative Tectonics, was published recently by Springer in the book Robotic Fabrication in Architecture, Art, and Design, which was published in 2014. His new project, quote, City of Breeze, will be published in the upcoming issue of AD. I went through a very long list of awards, and then I thought, you know, I'd just say that he's just been sort of the recipient of many awards, but I should note that among them is also awards for his teaching. So we're really thrilled to have him this evening. Please welcome Philippe Yuan.
So thank you so much to the kind introduction from Dean Amal. It's a great honor for me to be invited here to make a speech in GSAPP. I think you play a leading role in the world, especially in the last 20 years, because Columbia University, especially from the early time of digital world to now, I think still leading a pioneer knowledge and architecture future in the world. So today it's great honor for me to present my research and some of my design works to you, and looking forward to make further discussion on what you are doing and make further discussion on the future. So I'd like to talk about the topic today as matter matters. The pedagogical agenda right now is to expanding upon the design methodology developed to acquire an understanding of the interwoven relationship between the visualization and the materialization. I'd like to extend the subject matter to include the process of formation, simulation, optimization, fabrication, and even industrialization of the discipline of architecture. Perhaps most important of all, however, is the fact that the science itself is now able to offer insights to help us understand the cultural life in general. And that framework like new materialism can help us make much needed connections among the discipline and also in the society. One such insight that matter can be seen as active is an insight that can help us to understand not only how matter itself behaves, but also how society itself operates. As such, the notion of the active matter has implementations beyond the strictly material, the material world of matter itself to embrace the whole of the society. Also from the scale of the nanotechnology to that of our cities, countries, and even the whole planet. The message is clear. The behavior of the matter, especially the active role that it plays in its own formation, can help us to understand the broader questions about how the world operates. In short, matter does matter. So this is an interesting structured performance simulation put forward by Mike Xie, who is a comedian from RMIT, Australia. And he made a very interesting simulation by the hanging of 1 point and 2 points. So 1 point, the apple is the best form in the world. And the 2 points hanging, the best form is Catalina arch. And also the simulation of the Sagrada Familia, the facade designed by Gaudi, is also based on this kind of thinking methodology. So from this kind of simulation, we can understand what is the best form in the world. So in the lecture of Mike Xie, I put forward a question to him. If you're talking about the hanging, the apple is the best form, why we have the pear? It's also have a hanging, but it looks different to apple. So that is the question to the simulation, is kind of technology. Are they, this kind of new method will totally change the thinking process or replace the designers? So the question Mike Xie gave to me is not only the hanging point, but also the seed of the apple and the pear are different. And another force is growing as a nutlet in the middle of this apple up here. We also have another forces to change the apple and the pear growing differently. So I think the human and machine right now are collaboration with each other. It's just like the hanging point and also have a core, a seed inside the core of the creatures. We produce a different formation process of nature. So tonight I would like to put forward 3 topics from new materialism, craft-driven materialization, to human-machine association. The new materialism moves us beyond the discourse of representation to a discourse more aware about the material process and expressions. Yet it's not that new materialism seeks to displace or dismiss the representational logic of the late 20th century, although it were redundant. Rather, it seeks to emphasize that after years of stressing the importance of representation, we need to redress the balance by paying greater attention to process. Indeed, there are 2 discourses of representation, of the process, are not mutually exclusively. but the one invites the others. I will introduce several of my projects and think about how the material reorganized process engage into the design process. This is a cable car station we designed in Qiandaohu, which is a beautiful scenery in the Yangtze district. So the project is developed by a huge developer, including 200 hectares tourism project on top of the mountain. They invite us to design a cable car station, which is like a welcome center of the whole scenery. So we are thinking about the new landmarks, how can embracing the new travelers and also bring a different experience to the visitors. The original concept is coming to integrate the building with nature and how this kind of building can grow in from the mountains. And also it can anchor into the rockeries. I hope when you have a first glimpse of the local scenery, it should be different to figure out where is the building and where is the nature. So that follows Chinese philosophy. Man is the integral part of the nature. Well, how can we manipulate the design process to realize the conceptual goals? Here is the formation process. We define an agent system that could represent the simulation process of how the rockery of the mountains grows up. And the protocols represent the intelligent rules of how to predict the future, the growing process of the rockery to the building. So the basic logic is coming from the local topography of the mountains. So architecture is the landform we're looking for, and the landform is the architecture. So this is the form finding process. From the prototype, by the bottom-up process to simulate how the building growing from the rockery to expanding out to fit into different kind of functions of the buildings. So this is models we make. And here is the final models to represent the process. But actually the process is not just a final result. It's a growing process, how to integrate with the programs, with the geometry of the mountain. We have a very big cantilever touching out to the cantilever to the lake. So we have a beautiful scenery in front of the mountain, and also the cantilever make a shading space for the parking, and the people can come in outside and sitting outside as entrance of the national park. The cantilever is 30 meters. It's very big, pushing out from the mountains. So it's different floors. The plans still in the design process is important because different height should be carefully operate different details in the design process. And also can find the reflection of the water and the integration of the local material. It's a kind of laminated bamboo. We use them as a facade to the building to make it very close to the local materials. And also we set up different systems, including the structure system, most importantly because it's a big cantilever. So it's a steel structure system anchoring to the nature. And also the structure system, when we make the construction, it's a very complicated process for different kind of structure simulation and the optimization process. And after finish the building, you can see that when the cable car coming down from the mountains to the end to the platform, which you can find the frame of the buildings, can framing the beautiful scenery in front of you. It's just like standing in the nature, and also the frame is set up a certain distance from you to the nature. So this is part of it finished. You can see the building with the mountain, the building with the lake, and with boat, the boating on the lake. So I would like to highlight the final images. Here is the original concept of the design is how to integrate the building with the nature. So actually it's the logic of the form finding process is from the protocols, the prototype of the rockery, and growing to the certain form fit to different kind of function programs. So when we leave the site, it's about 1 kilo away from the buildings. It's difficult to figure out where is the building, where is the nature. So that is dream. Also in the philosophy of China, the building should fit into the nature. It's growing together. So that is the basic idea, how the growing process, the form finding process, make the whole design the concept. The second part I want to introduce is another tools we develop in our office, the wind tunnel. Normally, the wind tunnel is in structural engineering school. They spent a long time research on that to make millions RMB. It's very expensive. Normally, it's difficult for designers to use it. But we're trying to develop this kind of low cost and also design-oriented visualization process in the design. So the wind tunnel could be part of the design partner in the early design stage. So this is the first wind tunnel we made. It's around 4 meters long and something like this. And the first one could make the simulation, the scale of 1 to 500 or 1 to 1,000. And this is too small scale. So we'll make the second one. This one is 12.3 meters long and can simulate the scale 1 to 200 and 1 to 300, the high-rise buildings. Some details. And after that, we change different section of the wind tunnel to help us to make different kind of simulation. The left one is about the smoke vials, can visualize when the wind passing through the buildings. And the right one is we can change different location of the buildings in the urban environment to have some feedback about how the ventilation, the wind can change the formation process of the design. So this is the real one. We change different kind of things. And this is a smoke vial process. We put in the high-rise, like Lego is the early form finding process in the wind tunnel, and use camera to record the videos and slowly coming out to simulate the process, how the wind passing through. And also we use this kind of scouring experiments to test, use sand put in on the ground to test the pedestrian height people, how we can get feedback, the form of the wind in the podium of the architecture. And also this is different simulation. So the left one is the smoke vial simulation for the certain height of the building, of certain geometry of the plan, typical plan. And the right one is a simulation by CFD. And the bottom is testing the pedestrian height, the wind performance. So through this kind of experiments, we can very fast got some feedback of different geometry in the design process. And also we try to use not a stable building. If, for example, not one single building. If we have 3 buildings, 4 buildings, if we can change the location and change the initial logic for the form finding. This is twisting system we make through the Arduino to make the automatic process to make the form finding. So this is the process we can see for the form finding by itself, the twisting by the location of different buildings to make the form finding. So the result is interesting because we can figure out if the podium should be twisted or the top of it should be twisted, different angles will make different geometry for the high rise. And based on that, we participated in Shenzhen Biennale 2016 and win the award in Shenzhen Biennale by the methodology we use in the wind tunnel. So it is a huge model. We make research on the isolated district between Shekou and Qianhai, 2 districts. Originally, it's a very long railway track, so keep like 80 meters width and 12 meters long width district. We try to make research on this district and we use the idea if we can design a certain kind of infrastructure system. I think in Shenzhen, if you visit China, it's a very good location for living because people can live there maybe all the season, can stay outdoors. If you have shading system or have good ventilation, it will be very comfortable to stay outdoors. So we try to put forward the idea if we can design an infrastructure system, can control the pedestrian height, the wind speed, and people would like to stay outdoors and would like the high density street life. So the infrastructure system for the high-rise is not the programs like the apartments or like office and hotels, but could be some public function for the city. So this is the matrix of the wind tunnel, the wind tower, and which can control the certain scale of the urban space. If the wind is comfortable and the shading is comfortable, we can produce a very livable and livable space in the city. So that is the basic idea based on this kind of new technology simulation. So we can see the video in this waste isolated land in the downtown Shekou. The right hand is Shekou, the left hand is Shanghai, which is a true, very representative developing district. But in the middle is isolated space because of the railway cutting through. So the government would want to reuse this piece of land. So we put forward the idea to set up just an infrastructure system to change. Maybe in the future it's a bottom-up research development process, and also this kind of big canopy with a very high chimney or the wind tower can control certain kind of scale of the urban space and make a different urban future. Although the typology in China is all the high-rise are similar, like New York City, but we're trying to, in the Shenzhen Biennale, we're trying to put forward if the infrastructure system, not just horizontal for the pedestrian, not just hidden underground, but could be vertically change the urban quality, the wind, and put the bird tower, put the plants tower, and put this kind of observation functions in the buildings. And also we make some very small high density, super high density blocks in the ground, on the ground, and which can grow in slowly in the city, and it could be reorganized by itself. Maybe it's a utopian process, but we put forward it's an idea for the future Shenzhen. So the infrastructure can link in two parts of the city, and also based on the traditional railway, we can make some commercial programs and the shading of the super big scale infrastructure system, and also the wind tower can produce some public functions for the future cities. So the model is like 100 square meters. It's a very big model, but we spent only 1 month to do it because we use this kind of robotics to cut and make the formation process for to the high-rise and the formation process. So this is a podium for the high-rise. Okay, this is one project. So it goes to the second part. I would like to talk about some of our early work, craft-driven materialization. Well, some of the projects are based on the understanding of the new materialism as a generation process in mere material itself. We have also begun to explore deeply the human-driven of material formation process. Here, what I mean about the human-driven is referring to the production aspects of the building life rather than going into the discussion of constructing particular human experience. So the craft also becomes the driving factors in our design process to review the relationship between the human and the building form in the materialization process. So this is a project we designed in 2008, which is actually my office. When we arrive in the location, it's not a safe district because it's a warehouse district, already isolated for more than 10 years. So we make a renovation based on, this is a silk industry warehouse. So the inspiration, the concept is from the silk. If we can make some facade system to keep my office safe, actually, at the very beginning. So the silk have some kind of greenness. So the fundamental concept is coming from the greenness. If the greenness can make certain kind of performance of the facade, so we change the greenness to the rotation degree of the bricks. So that is coming out the concept. So bricks is extremely cheap material in the construction site. So we select them and make a design by this kind of diagram. So the detail drawing here is not the detail like the other buildings, but we design a certain kind of ruler, and ruler is like a modular system to label them with different numbers in the detailed drawings, and teach the workers how to position them in the right location. Just a ruler put there, and the workers can put all the bricks in the right location. So this is the local workers. We work with them as they spend only like 2 months to 2 months to construct the whole walls of the buildings. And the details of the facade is the elegant thing is from this kind of rotation. Rotation of the degree of the bricks can make different kind of performance for the facade system. So this is one of our early work. And the second one is a tea house, also in the J office. It originally is a tree. Normally when we make a new building, we'll cut the trees. But we want to have a concept coming out if the building can sit in and embracing the tree with this architecture. So this is interior space. So original concept, if we going through from the ground floor to the second floor, we can embracing the leaves and the branches of the buildings. So the geometry is setting up two kinds of frame. One is the entrance of the stairs. Another is when you're passing through getting onto the second floor, you can have a frame of all the leaves and trunks of the trees. So it's a two geometry as kind of transformation by some roof surface for the design. And how to construct it is that 10 years ago, we're facing this kind of problem. So we make a 1-2-2 model in the left corner, and teaches the workers how to construct. Because the drawings, they can never understand this kind of very complicated geometry. They cannot construct it. But follow the model is easily for them to position and to construct the whole buildings. And after that, in 2015, we were thinking about from this kind of basic fundamental tools, if we can generate some form more meaningful. So this is a fab unit space on the west bund of Shanghai, which is a gallery space. So the function of this is make certain kind of exhibitions. We have two kinds of programs. The right hand is 2 5-meter tall buildings, the left hand is 3-story floor. So how to make connection of them? So we have a special circulation space in the middle. And we're thinking about, because concrete structure can never have a span like 50 meters. So we want to make the circulation to be a structure system. So how the structure system can be not only the circulation system, but also could be the structure support system. So that is the original concept for the design. So in the design early stage, we make some analysis by the circulations, how to connect different heights and in the different sections of the space, and which is a circulation logical diagrams. And followed by this diagram, we're thinking about to use this kind of 3 meters width space to make a stairs. So right now, we use the methodology like the Apple form finding process, which is a BESO algorithm structure performance simulation, which can reduce the concrete to, if we left some material that is useful material. So we just reduce the material step by step. So this is a process. It's whole concrete and reduce the material step by step, generation by generation. And we make models to present this building in GSD last year exhibition. So left one is a solid concrete system. And step by step, we take away reduce the concrete material. And by this kind of BSO algorithm structure optimization tools, we can find the form like this. So this is the design process. So in this case, it's totally different to the first building we present, the tea house. The tea house is just geometry is a form. But here, the geometry transfer to a structure system. So in the construction process, we need to think about how to construct the buildings. From the plans, we can see the wall and the floor is very thick. But actually, it's not so thick. It's just because from the section, it changed to be very thick. So, and also we join a lot of sections and try to teach the workers how to construct this building. But it's never worked because this kind of sections can never represent the real depth of the floor because it's all diagonal. It's cutting through it will be extremely waste. So we make a lot of models actually to teach step by step, floor by floor to the workers. So the models change to be very useful in the construction process. So after the building finish, something like this. The folding walls change to be a support structure system for the whole building system. And it's not visible from the origin. Normally the building should be straightly, the forces from the upper floor to the downstairs. But in this building, based on the simulation tools, the forces is transferred is folding from the second floor to the ground floor. And the inside edge is stairs. So you can go inside the stairs and go outside to open stairs, and then go inside to the inside stairs. So it's inside-outside process, make a different kind of experience in the building when you're walking through. So from the bottom of the stairs, you can see it's very heavy, although it's only 15 meters width. So the light, we use two lights. One is the roof light, is washing the concrete wall. Another is parallel light, it's also washing the whole space. So we're showing two kinds of darkness of the concrete and showing the heaviness, and which is volume of the whole buildings. Have a very strong experience when you're passing through these buildings. At night, lighting up the building like this. So when we go to the second floor, you can see the left hand is the outside stairs, and the right hand is the inside stairs. So from outside to inside, the folding and unfolding process, we totally have a different experience. So the forces passing through is not vertical, but like this diagonal, the forces from here all the way to this point, and all this weight is from this stair to another flight. So it's not a vertical forces flowing system. It's a diagonal forces flowing system. It only could be simulated by the computer. So right now in this project, we're thinking about the machine, the computer, can collaborate with the designers to make some new form, more meaningful form. And also, the designer can think about how to organize the circulation process from inside, outside to make different kind of experience. So we make a lot of events in this project, including some national famous dancers. They make special event, and also some composers. And this is a project of the artist, present different kind of work inside the buildings, which has a different kind of dialogue to the space. So third part, going to the human and machine association, what we're doing in my office. So the machine being introduced into the building industry, the materialization process of the form would not solely rely on the labor of human being animal. So the definition of craft could be also transferred by association between the human and the machine. So in this scenario, we believe that the craft should not be interpreted as just the partner, a particular way of putting material together, but has to expand it into the reorganization of the building production system. So as a collaboration between the human and machine, the world performs a new way of construction. So this is actually in my design office. So I think we are the first in the world to have a robotic lab inside the design office. Why we do that? Because we're thinking about the designers in the future is not designed by the computer, by the models, but we should making the building by yourself. We can invent some special tools, and that could be a certain kind of authorship for the future designers and make the buildings more meaningful to the designers. So on this platform, we make a lot of experiments. So our idea here is from the practice to praxis. That means we make furthermore research in my office. This is the whole site of my office. We have an exhibition space, we have a courtyard, and we have a robot yard, and we have office space, and also have the tea house. So the process of the office is growing. It's also a process. The top one is 10 years ago, and it's slowly going on. And right now it's something like this, because ivy is growing, the surrounding, embracing the whole office. Indoor, outdoors have a certain kind of dialogue to each other. And in the exhibition space, we can figure out all the models tracing what we're doing, different kind of experiments in all of our projects. Yes, actually a lot of mock-up, one-to-one scale mock-up in the office, because we try to test the material, the making of material, and to redesign the process of the materialization of the future architectures. And also the laboratory, we have a lot of tests, and most of them test to failure. This is one of my PhD students. We're doing some experiments on the timber structure. So we're thinking about in this kind of laboratory life, the ultimate objective of research is to experiment. And through this experimentation, we want to establish a new kind of credibility. Because the credibility for the future generation is not just meaning you can design a building, but if you can design a tool, it's also meaningful. And actually, the signature and credibility for the future architects could base on not just you can make a spatial, meaningful test, but also you can set up a new kind of tools with you in the office. And in this situation, we're trying to figure out the relationship between what is practice and what is research. And in this situation, we could create a very interesting relationship between the design research and the building practice. So analog to the Latour's notion, what is the scientific result of the future architecture, which has the meanings to position us in the new networks. The networks is not just one university, one professor, but it should be the networks of a lot of new generation, like the artists and the architects from all over the world and professors from different places coming together. That's why in the last 7 years we set up a Digital Future Shanghai special event. We make a group research on the robotics. We try to set up a new model for the future research. So for example, this is just one example on the research of the bricks, from line to wall, how to use the grasshopper to find a certain kind of form. This is also another grasshopper model to set up different parameters. The parameters can change, we can change the information, the data, and to make this different kind of form. But the form is not easily for construction. But based on our tools, it will be extremely efficient if you want to make any brick, any form based on the bricks. And also this is from surface, not from line, from surface to the wall, from box to wall. We have different kind of toolbox developed. And the most important for brick mention is the overlap part, because that should be based on the finite element simulation and optimization process. But the overlap should be carefully calculated in the computer by the structural engineer. But based on certain kind of tools, we can implement the tools, the grasshopper plugin tools, to design the reasonable form of the brick walls. So this is a process of how to put the rebar and how to make the organization and how to bending the rebar for certain kind of twisting in this kind of brick walls. So it's all the toolbox development. This is just one example. So we develop not just the design process, we also develop the tools, the on-site robotic machinery equipment. This is the generation 1 we developed in 2012 from model to construction. So we use these tools, how to make the machinery equipment to feed the bricks and how to make the equipment work. And this machine, we first do this wall, because the twisting wall is all different. We need to position this equipment 4 times on site to position each brick on this position. But this is too small. The robotics is very small. It's not very efficient. So we developed a second generation. It's like this. So this is all the drawings and the robotic tools we developed, including the motor feeding system, and also this is the bricks, how the bricks supply to the robotics. This all the details we did. And the most important is how to make the navigation in the inside space. So we put different kind of UWB sensors and use the laser moderating in the space and help the robotics position how to find the right location of each brick. And this is orthodox. We use Kinect tools to help the robotics to put the brick on the right position. And this is a simulation in the computer and the construction I will show you like this. This is the tools we develop. And still we need workers to clean all the details. Yeah. But this is a basic process. One of my PhD doing this. Yeah. And use this special generation 2, we make the wall like this. The brick layer walls, and the inner is the insulation, and another layer is the concrete. So put this sandwich system of the architecture system. Architecture facade system. So this is building we design, and we teach the fabricator to buy several robotics in their factory to make the wall. It's a prefab in the factory, pieces by pieces, sandwich style, and hanging them on site, floor by floor. So this is a process. I wanted to put the example as the human machine. For the designer, it's not just design the facade, but we design the whole process, including the equipments, including the tools, how to construct the building like this. Another one is 池设. This is on-site work. That is prefab. And we go to the site, and this time is more challenging because location is westbound of Shanghai, Huangpu River, and about an airport district. A lot of waste warehouse, a lot of waste bricks everywhere. It's an urban renovation project, and 2 artists want to develop the art gallery space. So we shrink the initial wall, exterior walls, and followed by the elementary performance and structure refinement in front of, in order to provide a maximum expansion space. So the concept is to gradually change the bricks, and from wall to the rain shade canopy. So it's kind of from the typography to the topography of the space. So the integration of reused brick on site, because this is roughness, it's not accurate, but the robotic can do it very accurate and precisely, put them on the right location. So it's very interesting. It's very rough bricks and make very precise and accurate position and make the building very special. So the bricks coordinate with the building have been applied to the exterior part located on the main interface towards the park. The contrast between this kind of roughness and the accurate make a speciality for the buildings. This is a facade in the poster. And the right location is here on the riverfront of Shanghai. The design process is not so easy. Actually, we evaluate as architects. We use some structure performance imaging tools to simulate the displacement, the stress, the wind load, and also how to integrate this kind of different performance, structure performance, to design the density of the material and to put them in the right location. It's all the form finding process to simulate precisely brick by brick and teach the robotics how to construct locally on the site. And also we have some steel structure hidden in the back. The roof structure has been replaced by a lightweight timber structure. And we also evaluate part of the roof to make light coming in and to lighting on the special wall to make a special space for the gallery. So this is the lab, and based on that, we would like to introduce a project which is finished 2 months ago. This is a project collaborated with Archimangus and my team. And Martin is one of the PhD candidates from University of Stuttgart, come to Shanghai and collaborate with 2 of my PhD candidates. And they spent 1.5 months in my lab to construct the whole pavilion in Shenzhen. Shenzhen newly opened a contemporary art museum, and they collect these pieces. Right now it's still an exhibition in Shenzhen right now. So we use plywood as a material, and also the sewing machine could be special tools to make the new material performance of this installation. So all the details are specially designed, and all the formation process is based on the structure. If we're folding them, we can have the self-support system to standing up by itself without any other hanging material. It's a self-standing structure. 2 layers of the plywood, and sewn by the machine can make the certain joints. So the sewing material is carbon fiber, 2 centimeters radius carbon fiber, to weaving the wires of the plywood. The plywood is 3.5 millimeter width. And also we cut it by, in my lab we have a 5-axis CNC, and pieces by pieces cut all the components and folding them to certain form and sewn by the robotics. This is a future architect's work. You not only design, modeling in front of your computer, but also the making whole process. You participate, and also including inventing the certain tools to make the certain form and certain pavilion. This is only the pavilion. And after this, actually parallel to this, we make another toolbox, which is a 3D printing technology. So generation by generation, from the left one to the right one, we spent 5 years to develop different toolbox of the 3D printing. And also material from ABS to modified plastic. We try different material to test materiality of the printing material. This is in my undergraduate student studio. I asked them to how to print a chair. So methodology is the same. It's a structure performance based design by the density of the structure of the chair. And we translate this kind of density to the tool paths. We develop 5 prototypes which have different lengths of the printing paths and can print in different density of the chairs. This is the final result for the undergraduate studio work. This is another one. This is the tools we put in the studio. And that one is a simulation one. This is a real one. Although it's some different, but this kind of roughness gives very interesting of this chair. And also we designed 3 people, it's triple people bench project, which is based on the geometry form finding process and also the structural simulation, which could be standing safely. This is a rendering process, modeling process. This is the structural simulation process. And the whole printing process spent only 15 hours. So it's kind of customized products. In the future, if you can have a very good design thinking, you can make by yourself, by the students, even after your graduation. You can set up your own business on the furniture making. This is a single chair by one of my students. With a different material percentage, we can have a different materiality. So this bench printed only 7 hours. This chair. And after that, we don't think we just can print a small chair. We want to print some structure. So we try to print a wave bridge inside our university. So this is in front of our building C. One bridge is cutting through from the ground floor to the basement. Another is cutting through this small pond. The big one, the net span is 11 meters, and the small one is 4 meters. The whole design process is, firstly, is Kangaroo is a structural performance simulation to find the form of double curve, the upper curve and the lower curve, and between that we can make some other material. So this is the first step. We use some structure performance simulation to generate form. The second step is to reduce the material, the same to the idea we put for the Apple tools. So the mid-patty can help us to reduce the material. So the last one is only the printing path is the minimum material we use for the whole bridge. And then it's too heavy. We cannot make them one pieces. We need to cut them into different components. So we need to simulate by another structure software is Karamba. It's also a structure simulation tools. And this one is for the details. Abitare, another structure simulation software. So totally we can collaborate 5 kinds of structure simulation tools to generate the bridge and simulate if it's safe enough for the 5 people to passing through the bridge. And after that, we print it. So the printing pass is the minimum pass, and we can save the material. So totally we spend 320 hours. We use 3 robotics printing them in 7 days. So in the workshop it's like 8 days. So we print them and construct them in very short time. So the construction process needs to be designed, how to put everything safely, step by step, set up this building. So this is from the morning to the day and night, 20 hours working by some students and 2 workers. Construct the whole bridge on site inside of university. And the early morning, I was asked to see and asked me to be the first one to passing through the bridge. It's around 8 o'clock in the morning. So it's a special time to be recorded. A little bit scared. But the safety, yeah. So after this, we're printing the bridge. A lot of students and professors, not from our school, but from the material science school and also the structural engineering school, they're asking a lot of questions and put forward a lot of interesting suggestions for future study. And in the opening of exhibition, Patrick Schumacher coming, and 2 of us passing through the bridge. This is the time. And this guy, the second left, is the Secretary General of China Architects Society. He came to visit and asked me how many people can stand on the bridge. I told him 5. He asked 5 boys and gentlemen standing then, but it's very safe, so standing on it. So after the bridge, we are thinking about if we can printing even bigger by this methodology: structure, performance, simulation, form finding, and printing technology. So 4 months later, we print a pavilion in Shanghai, our season last year. This is a real pavilion. This is the form finding process. First step is geometry form finding. So the most difficulty, how to make this geometry stand. So we need to use different kind of software to simulate the structure system, and how to simulate the density, which part should be strong, which part could be weak. So it's changed to be the density of the material. It's same to the chair. We're teaching students printing the small chair. We're using the large scale and the same methodology. So different density represent the 2 paths. The printing long or printing short can make the density of the whole pavilion. So this one we print almost 1 month. So the whole process simulation is all in Grasshopper like this. So all the printing paths is simulated in the computer first, and simulated in the printing process by robotics. And then we're printing them by 3 robotics in 1 month. This is the printing process by this kind of plastic. Step by step, 24 hours. So after the construction, it's like this, self-standing safely. If they're hidden in the greenery, the semi-transparent, it's quite different feeling in the nature. In the opening of the art season, RCR, one of the principal participated opening, and Yunho Zhang and also Evan Douglas from RPI was in the events. And right now what we're doing is for the Venice Biennale, for China Pavilion, we're painting a cloud village. It's not just one building. So in my office today is still, all the robotics are printing right now. So this is we announced this is public announced first in Colombia. We will, the pavilion will be exhibited at the end of May in Venice Biennale. It's one of the most important pavilion in China pavilion. Yeah. So it's totally 250 square meters on the surface of the material. Not only the plastic is reused material, very meaningful in China, because we can reuse different kind of plastic in the future if we can implement this technology to printing some structure or some installation. At the same time, robotic is the tradition methodology. We're very fast going through. The left one is our research, the right one is our real project. So the specialty, this is traditional laminated process for the timber structure industry in China. But we help them to develop how to update the version of the timber structures. This is the tools we develop in the robotic factory. We can cut in very fast the curve beam and the curve column. This is tools we develop and teach the fabricator, the industry people, how to precisely, without any news, it's just this self-support system for the future building system. So through this, the right one is a simulation in the computer, and the left one is the real production making process. So this is the future architects you need to understand. What's your job you need to do? If you can connect directly from your office to the fabricator, that is totally redefine the discipline of architecture. So this is pavilion in 1 week. In Digital Shanghai workshop, we make the left one. And then 6 months later, we designed the expo house in the horticulture exhibition in China, the building. This is construction process. All the beams are curved. And it's a double curvature roof system. All the joints are different. How to make the joints? We need to develop special tools. We are not the fabricator. We teach, but we teach the fabricator how to update their tools. Because this is a diagonal pattern through. The human body cannot make the very accurate angles to pattern through, but the robotic can precisely, efficiently making this. So it is design process. And very fast going through this. So the double curvature service of the buildings is a self-support system, all the compression of the material. And the joints of it, we have some steel joints in the middle of the timber structure. So it's all diagonal. So the tradition industry cannot make it. So we develop only one robotics and teach them that every joint spend 40 minutes to milling them precisely for this building. So my office sent all the files from Shanghai to Suzhou to the factory and make everything. That is the future works, the design office you need to do. The special part is it's a diagonal, yeah, precisely. So after construction, the space is like this. It's double curvature. All the joints are different. So last project, going to the in-bamboo project, because this is in the village, in the rural district of China. Which is very difficult to control normally because it's far away from the town center, and how to design and construct this building. So we make two courtyards which connect to each other because originally it's a two family, but because the young generation all moving to the big city, so it's these two courtyards was almost crashed down. So we redefined the geometry to link these two courtyards together through double curvature roof. So the form finding process is something like this. But the most difficult part is how to construct it. So we use the same methodology, the beam, column beam system, to make the roof system of the building. So this is the different layers. So the special part is we collab with the same factory because we teach them how to use robotics, although all the joints are different, but they can make it very easy because this project is easier than the formal project. But they know how to use the new tools to develop this kind of structure system. So the real construction process. And also we have drawing sections, something like this. So in bamboo showing the kind of Chinese philosophy, it's kind of hidden and escape from the town center, but it's collaborate with the vegetable field, with the trees, bamboos, and hidden. It's a kind of screenery, new screen of the buildings. And also we designed the entrance pavilion, use bamboo as a material for the geometry form finding process. This one we collaborate with local craftsmen. The weaving process, welcome people enter. From the hidden to figure out where is the building. And then we have two courtyards. One is a courtyard like this, another one is a pond. And we can find a connection to make the public space, special exhibitions, and also some seminar was held in this community center. And the roof is a local material, and facade is weaving bamboo. So it's all from the tradition, but actually use some new technology to make special filling of the buildings. Also local villagers planting the vegetables in the field, which has a dialogue to the building and the field. The interesting is you can find all these workers are eldest people, more than 50 years old. And I take another picture, you can see most of them are the females. Why? Because their son, they go to the universities. After their graduation, they don't like to go back to the rural district of China. And also their husband maybe find a job in the construction field in the big cities. So there is no industry actually in the rural district of China. So I pushing out after this project to the government people, if they can set up a small robotic factory to help the local people to update the version of their villages. So right now it's a good, I got an invitation to renovate not just this building, design this building. Right now we renovate the whole village, including 85 families. So we design 7 public buildings and also teaching all the local villagers, they can learn how to use this kind of timber structure, tiles, and the traditional material to construct their home. So the technology, the materiality, the making process of architecture, I think finally should go to why we design and who we design for. I think the material really matters, the social networks, and the responsibility of the architects for the whole society. So this project was luckily selected also for the China Pavilion. We'll exhibit in the May of this year. And we will present not only the In Bamboo 1 project, but also you can see the white project is some public new building, including the camps, summer camps for the kids. And also we have some welcome center and have some other exhibition space for the local bamboo weaving industry, this kind of buildings. And also we update the version of the infrastructure system of all the canals and this kind of things. And we hope we can present a different countryside, a different industry in China. So that is what I'm doing, and hopefully we can make some further discussion on this. So thank you for all of you. So this is dog, because Chinese New Year is a dog year. And one of my students, last night, he used robotics to join a little bit long, 1 hour and a half.
Is this working? Don't go, we unpack Philip's life now in less than 3 hours and with less than 5 questions. Okay. Thank you very much for being here. I would like to engage in a conversation as we move through the next couple of minutes, but before that I did do my homework and would like to do a 3-sentence reply along the lines of old meets new before old gets new again, which is kind of a challenge when it comes to fabrication and like modes of parametricism and production, particularly at the time where you can look at projects through the lens of software and determine their age based on what software was used, which is not the case in your project. Archi-Union's research and practice focuses on integration of traditional materials, as we saw and realized in some of the really excellent modes of engagements that you shared with us, but also computational design and production technologies, discovering both the local within the global. If I would ask Philip for Philip's response, it would be along the line that fabrication can be framed through formation, simulation, materialization, optimization, and industrialization. What I would like to offer, and also in response to what I discussed with my students earlier, is a 6th point here for you to take with you Tongji and like to Archi-Union from Columbia GSAPP, which is a point along the line of identity, the one way or other, looking at it through the lens of what global means within the context of local. And maybe a completely new understanding of it in terms of its meaning, but also a recognition of somewhat not all that new reality. Identity within the context of re-identification, a kind of complete absence of the local, which also exists, particularly the absence of homeland in whatever terminology we want to define this, forcing refugees of war, climate, economics, hostility, or hostilities, I should say, to take on, adopt, often invent completely new identities, but also identity in the context of changing environment, climate, that we are exposed to now rather than, let's say, 10 years ago in a kind of pre-iPhone world, where identity allows you to curate image on a screen. Your kind of like local becomes WhatsApp. Your kind of like global context and address, the one way or other, becomes your Instagram handle. But it's also influenced by what you write about in, I believe, Digital Reality, right? Like that you published in 2011, which kind of like links to the tectonic identity or digital tectonic that you spoke about. But then also tectonics in terms of crisis or identity in relationship to crisis. Crisis as an identifier, but also crisis as a generative mode, right? Like in terms of absence of materials, the desire of optimization, but then also the crisis within the question of what does singular mean within the context of collaborative, right? Like where the office, atelier, collaborative, or group becomes plural rather than like that single architect's entity. But then also looking at examples that make architecture then again look kind of like old, right? Like when Sin Malik is doing poetry, Virgil Abloh is working with, I don't know, Nike and Converse. But then there's also groups around the corner of your office that I'm particularly excited about, particularly looking at what some of us did on the weekend as part of the Asia Incubation Project that presented like as part of New York's Fashion Week, namely looking at Hong Kong's Kawaki, then Vlida in South Korea, Fumiaki, Oyo Wanaka, Haiyon Lee, and so on and so forth, that completely define and redefine the norm of identity in a way that questions of gender, locality, but then also global and local is challenged through, in fact, something that relates to the body in a very different way, which is, in that context, fashion and identity through them coming from architecture, moving into one of the kind of like challenges that very much relate to also fabrication, as you speak about the body and like the relationship of the body to architecture. Before I move to my first question, I would like to like add 0.1 like to that sixth point, which would be the one of geography. I found it incredibly interesting that you use narrative, multiple narratives to define your work. If there's one unifier, it would probably be space, the one way or other. Some may think that this topic is for like physicists or architects in general, but you approach space within your work, I think, as a geographer. We had a chance to speak about Doreen Smassi's work earlier, who is a geography which looks at history and time within the relationship of space along the line of what geography means in the context of space, not outer space or space in meaning of atomic space, but any of the above. It is space that is a dimension of world in which you live in, or the projects that you situate in. But they do concentrate on the temporal dimension and how things change over time, rather than concentrate in a way things are arranged in the sense of like outer space in relationship to geography. Which leads me to my first question, which is the one of like what you think about the architectural vernacular within the digital that I think takes a very different approach than, for example, you showed Schumacher on your screen than, you know, parametricism does and like their work does. Not only because making comes so close to it, which is very close to our heart here as well, but it kind of also neglects the fetishization of fabrication. Would you agree with this, or?
Yeah, I have some discussion with Patrick, the similar topic you put forward. I think the discussion is talking about Patrick is trying to put forward is a kind of style, is a kind of a new paradigm from the form, from the formalism to the construction, the influence, the whole society networks, and understanding like it's like linguistic ways for the future architecture. But I want to put forward my idea is that is maybe a global thinking and design methodology, but the materiality changed, the material making process changed to be a very local things because you can implement this your invention of the tools to generate totally different materiality and the making process of the building and of the installation. So I think the materiality and the material process totally is a kind of debate, and it's kind of it's kind of totally disagree to what's the Patrick's understanding is purely white and without any folding and continuous and a differential facade. We cut it into the materiality. The skill of the material can give us a skill. The matrix of the 3D printing plastic and the bricks and also the timber structure all give the materiality and the skill of the building. So I think this kind of making process tend to be very important and interesting because the fabrication will put forward new possibility, new advantage to our discipline because that belong to the individuals, belong to the localities, belong to their cultural background. So that is even further than the globalization, the global process. So I think this global integration of the global and the local process will make something special. That is the credibility or the for the future architects.
Which is interesting because you also showed like caramba and kangaroos visualizations, which was exciting to see because Adam Molinsky, who was like one of the three characters that developed that piece of software, is an advisor to our like core structural software approach actually. So it's interesting to see at the same time, if I look at scale or if we look at scales that do carry different significance throughout like some of the projects you shared, which pair technology, handicraft, material sourcing, merging functions of different scales and facade patterns. It's hard to neglect this somewhat smartness that is tried to be projected onto projects, which is interesting because we just right in the same room had a very exciting conference with Laura Kurgan here on Friday looking at cities, where Laura looked at cities through the lens of it being a not so smart city, right? Like smart cities that are anti-smart. I was wondering when you look at smart fabrication technologies or equals, like in some of the exciting projects, do you think that equals smart architects, equals smart projects, equals smart cities, which then I think would lead to just that very basic question, which is there anything like anti or not so smart in the way you approach your projects?
Architecture discipline is a quite long history discipline, and something changed slowly. Although you can see the car industry, the airplane, the shipping industry, they already totally changed from the human labor to the machinic process. But the architecture is different. The materiality and the tradition building the whole construction process. And the most important is what the benefits the future architects can give us. Maybe it's not just abstract or the information process of the building, but it could be a kind of dialogue between the human being to the nature. It's kind of a new opportunity to create some space you like, some things you can like because you're from the locality, your homeland, your nature, your local landscape. That could be all the very important factors of the future building and the environment. So I read a paper several days ago, and the topic is about the the visualization and materialization. I think the big data or this kind of smart city, they can have a mining process and make a great use of the data, and it can help us to review, visualize a lot of things we don't know before. But that is just a method and process. The final objective for this kind of things is to still go through the materialization process of our daily life. And that could be still kinds of relation to our beliefs, our feelings, and to our what you like when you're growing up. So that is not changing so easily. So I think the new industry, new technology will change a lot for what we're doing, but it's just the future, and I name is a machine and the human collaborate future. It's not a machine replace human future. So I think the smart building is not the building like he is smarter than you, but the kind of smart technology help you to make a better experience, your feelings, and it's kind of dialogue of your behavior, so be more comfortable in this kind of building. So that is maybe the new technology can give us some new opportunity.
On that note, the pairing you're talking about, right? Like in terms of digital technology, traditional building materials is creating a variety of different also material effects or visual effects. Looking at some of the facades where the brick doesn't necessarily become the wall, but it becomes part of like its kind of image in its most powerful sense. Do you think that could be considered as part of the vernacular that you talk about itself, or is it based on the restraints that come from both robotics and the materials? And if so, if you look at construction like in the Shanghai Art Center, do you think that scale in pixelation is a dramatic shift in terms of how we interact with the building as an image rather than the pattern created that is very much a result of, yet again, like human assemblage? Trying to now make the link to what we are here very excited about in terms of what's happening this Friday, which is VisTech. If you're around, like, would be great if you could join as well to, like, think this through, which is kind of like looking at the interlink between visualization and technology, which is what you're talking about in your work as well. But what does the image do, and the power of the image in relationship to the kind of the building that you inhabit or that you imagine to inhabit? And the kind of asterisk to that is the lab that you showed, right? Like with your robotic arm being really the first one of its kind, which is exciting at the one hand side. At the same time, it's also exciting to look at the cloud lab, the lab on a chip, right? Like that you do in Tongji, as I know, the community lab that you're talking about within the context of Shenzhen, desktop labs that are like just purely robotic based. Is the kind of the spatial limitation of what you do and how you do it relevant to what the outcome is?
So right now what we're doing is actually not just we ourselves set up office or set up a lab in the university. In China, we set up the Digital Architect Design Association. I'm the co-founder of that association. I think 10 years ago, just Tongji University had robotics, but right now, 26 universities have robotics. Right. And also, we set up, collaborate with some local fabricator, try to set up some website to interweaving this kind of relationship from different material making process to the real building. I think the future of the design is a kind of digital twin. Left hand is simulation, the right hand is the materialization. So it should be collaborate with each other. It's a kind of twins, collaborate with each other, and we should have networks, not just one designer. We have networks important to integrate the social network system. So that will be totally redefine the architecture discipline, how we teach the students, how we learning when we are students, and how we work in the future. That we should be thinking about this kind of paradigm shift.
One of my last questions before we open this up would be, do you think that style or like type of pairing in terms of teaching is a trend that is globally specific with what you talk about in relation to its kind of site, right? Mm-hmm. Like, and geography of China in that context. Is this possible to, like, or did you, other than Tongji and some of the labs that you're talking about, to kind of like export? And if so, how would you imagine this to be integrated as a kind of like digital arts class, like set aside, or are there any material studies, like moments in terms of like what you also do at Tongji to be transported? Or how does the context of China and the specificity of how you relate to culture and labor change, not only what a possible export of it means, but then yet again, like cycling back to the question of like the local?
Yeah. At the very beginning, in the last 7 years, we set up the Digital Future Shanghai workshop.
Right.
I think some senior professors in the first 3 or 4 years, they totally don't like what we're doing, actually. Although we invited a lot of important figures from all over the world, like Archimedes, Anthony Picon. This is important. They make lectures, they're teaching, and Neil Leach and teaching with us. But a lot of professors don't like us. But after some time, I think we easily collaborate with some fabricator and industry people. Mm-hmm. That is interesting. Mm-hmm. They actually sponsor us a lot, not only in the workshop, but also in the real project. You know? So we publish some buildings, and we can doing that, and also we make a lot of pavilions. Today is not enough time to introduce everyone, but we make every year like 6 to 12 pavilions we make. Not my team. Yeah. We invited different guys coming, making teams, making pavilions. So these kind of things like a manifesto process, you know, to some professors. Right now, slowly, I think it's a large influence to the teaching process and how we can teach to study this kind of structure simulation tools. Originally, no one teach this. Sure. And how to teach robotics. But right now we can open some courses in undergraduate and graduate school. And parallel, I'm teaching the studio, for example. I will invited some of my PhD candidates, some young architects, and teaching with me. And it's like a certain kind of stream can push this kind of new thinking. Not all the studio like my studio, but I think we play quite important influence to the other studios.
Absolutely. Yeah. Thank you for letting us unpack this. I would like to open this up for questions, if there are any, and we further unpack. Greg.
Fascinating presentation. Thank you very much. Your work is brilliant. I was personally struck by your setting up sort of representation and materialization as sort of the opposite ends of how robotics can really manifest itself in architecture. It just seems to me that through your work, there's a lot of simulation that somehow ties these things together. Can you speak more about that? Because it seems to be grounded in many of the things that you're doing.
Yeah. It's a very good question. Actually, the simulation is the key, is a core process in the future design. In the digital twin, we name half of it is simulation, half of it is materialization. So simulation, including the robotics, before the real things happen in the computer, all the robotic two paths could be simulated. And also we can simulate the building in the environment. We can simulate the structure, performance in the computer. So we have a very long discussion with some of structural engineers in Shanghai last month. The structural engineers were about their future job. They're talking about you can use all the tools we use and how we can find our job. But I think I told them that's a different implementation because we use a structural simulation not for the real accurate details for the structure, but we just need a concept, you know. But some tools like 3D printing, we can use. It's like a package, you know, from the beginning to the end. It's totally from the architecture to structure to robotic fabrication. It's already a loop system. But the other, like timber structure, we still need some professional structure engineer to participate. So this kind of simulation will replace the jobs. Right now, we the disciplines we define. The structural engineer, MEP engineer, and architects, I hope in the future, if the computer and the plug-in tools is strong enough, the architects can implement just this kind of tools to help you to make a lot of design at the very beginning stage. Maybe the structural engineer only in the detail stage, they will participate to make it more reasonable to the construction drawings. So that is changing. It's really happened right now. So the simulation is a great design process. In the teaching studios, we spend a lot of time teaching the conceptual process, making process, but the simulation is a special part. That is across the discipline, not just architecture. Partly it's like the simulation of the environment. The ventilation simulation, we use wind tunnel, for example. It's not belong to anyone. The knowledge in the future belongs to everyone. If I want to make a wind tunnel, I spend only several months to make a wind tunnel. Although we adjust it a lot of times, but we can make it. We can simulate a lot of things. And then we'll give it to the structural engineer, and they will help us to make it more reasonable. But the original concept, the structure ideas already built in the very early age of the design process. So the future architects should have a lot of strong ability to know everything. Maybe you not develop a toolbox or a plugin, but you need to learn how to make use of them. So in my studio, I told my students, 3 days you must study a new software. So in one term, normally more than 20 software we use. For example, in the 3D printing studio, it's one term from printing a chair to printing a bridge. My students study more than 20 softwares. If we don't know, we invite certain people to teach us, and we can learn together with them. So it's a totally open system. That's why I admire this kind of workshop. I invited a lot of important figures in the world to Shanghai. We're learning a lot from them. They're learning a lot from each other. So I think that is a future education pedagogy system. The knowledge not belong to anyone. It will be a totally open source and a very fast optimization process. So we need to rethinking our discipline, our teaching right now, I think. Thank you.
Thank you very much, Professor Yuan and Professor Kumpusch. I have 2 questions. One of them is, you mentioned like what the future architects can do. I'm thinking about the much further future, like say another 5,000 years from now, when everything like disappeared, when they receive a ruin of the digital fabricated building, are they still able to imagine what the whole building system was like? I guess my question is, does that mean we need to think of new ways to archive the buildings and to archive our cities? Maybe instead of archiving like parts or like sample of the building, maybe we archive the tools or like the directions of the tools. Another question is, I'm curious to know, in the projects that you introduced, especially the one that needs the participation of robotic machines, do you imagine them, when these research-based projects move on from research-based to more like real practice, do you imagine them prefabricated at your studio and like fit in a vehicle and transform to the site, or do you imagine more like cooperations, like you mentioned, with the local government to open more robotic industry in the local context?
Yeah.
Thank you.
I think what we're talking about right now is not a far future. It's not 5,000 years later. We're just talking about what's 10 or 20 years, next 10 or 20 years will happen. So right now, actually, robotic factory is booming, not just in the architecture discipline. In China especially, I think the central government gave a lot of investment to sponsor the researchers. Actually, what we are doing right now is a 10,000 square meter robotic timber structure factory is under construction in Sichuan province. is totally supported by the central government because they see what you can do, they prove you can do it, then they will invest in it. So that is a good time for us. It's not just the imagination. I hope maybe next time I can make a lecture here, I will show you a robotic factory, what we as a designer to participate in the process to shaping the future industry. I think that's not the factory belong to anyone. That is the knowledge is invented by us, it's making by us. So I think what my interest actually is spreading out these kind of things to teaching them not just as a secret, or the authorship not just belong to me, I think it belongs to the whole society. That's why in the road district, I'm quite interested right now doing a lot of road district project. We teach the local industry and the local people to use these kind of things because some young generation, if they go to university learning how to use computer, they can learn how to use robotics. They don't need learn how to program it. They just can manipulate the tools. They can become the workers, robotic workers in the future. That will be meaningful. What we are learning and research and play our roles in the future is that could play a leading roles to change the industry. You know, architecture industry right now in China is 25% for GDP. I don't know in the States. That is quite as the most important industry in China right now. So the future generation, young generation, not everyone go to Columbia, no, not impossible, but some other young generation, if can learn how to use robotics, you can imagine how the industry will change the world, how the industry will change the future. So as a designer, we can put forward the building as an example, as a new demo to the public. We can do this, and this could be better and totally different to that. So maybe that will be meaningful for what we're doing right now. Yeah. Thank you.
Okay. One more. Hi, thank you for the lecture. I had a question with respect to this conversation of visualization, representation, simulation, et cetera. It seems like the work that you present is largely in the category, let's say, of visualization and simulation, and less, maybe as you alluded to at the beginning, in what we conventionally understand as representation. And I wonder what sorts of materials you might produce, or what motivates the forms before they need to be optimized, or before the materials are assigned. So, you know, what motivates a brick sheltering you from the rain, or a building in the shape of a figure 8, the things that other forms of representation might typically be produced in order to explore prior to the optimization of the form through the various technologies that you're experimenting with?
Yeah, that's a very interesting question. So who is the boss in the design process? If the truth is the boss, or the designer, the human is the boss. I think I'm talking about the future is not I think the past. All of us believing the creative architects can make a fantastic design. The Prize Prize winner, why he's great? Because he can make the unique cultural and architectural aspects, the buildings, just by himself. But I think the future is not just by human. It's already coming because the human and the machine are right now, it's like a collaborative partner. So maybe you set up office, your partner in the future could be a robotics, not a human. If your partner is strong enough, you can do together something different. So the tools is not building, I'm talking about some simulation tools. Traditionally, like Arup, this kind of big firm, they just post-rationalize the form the architects gave to them. Although they were strong, any Frank Gehry sketch, they can make a building. That's, I think, the last generation. But this generation, what they're doing is the structure performance thinking is a very, very early stage. The thinking, decision-making process can build into the early decision-making process. That is not just a concept form finding. That is one of the things in your mind. If you, this kind of logical thinking process can can collaborate with your unrational process. That's as rational or unrational can collaborate with each other. So how to embrace this kind of new technology is most important. Not to say no to them. I think I just say, why not? We should collaborate with machine. So we can make a different future, because although in the very early stage, conceptual stage, that will totally change the design process. So, and also I believe in the parametric is a good tool, because the parameters could replace a lot of information. It's not just a geometrical process. There will be a lot of information building this kind of data, this kind of information parameters, which will give the form even more meaning. It's not just for beauty. It's for the aesthetics, for the ethic, for the other meaning, more than geometry meaning in the design process. So that is a total thinking shift and paradigm shift, just in the form level. I think it's workflow can reshape the design thinking process.
If I could just follow up, I mean, I'm just curious because, say, a robot doesn't care if a brick is twisted or not. And so what is the form of representation that conveys to somebody that a brick should be twisted before the robot figures out how to twist it most efficiently? Does that make sense? Like, how does one represent the irrational within the work, what you're calling the irrational? Or does it only come in the final product and you somehow, you know, I think it seems to me that there's a sort of step missing, which is where the choice is made before it goes into the system. And those choices still have to be made outside of the technology, because the robot isn't yet making choices about why we twist bricks. It's only saying how we can best twist the bricks.
Let me give you an example. Compared to the soldier 1,000 years ago and the soldiers right now in the war, I think 1,000 years ago, without any guns, they just have this kind of knife and this kind of tools. It's just like the sword. And when they're fighting with each other, only we can see you, and it should be in certain very close distance we can fighting you. But right now, if you have a gun, you're just fighting 100 meters, 200 meters, you can fighting him. So the tools will change your thinking methodology. The representation tools, from the plan, section, elevation, axiometrical drawings, to the diagrams. I think the diagrams already is kind of visualization analysis process building the diagrams. The diagrams more than the traditional representing tools. So the tools always play an important role in design process. If you only join the sketch, you're thinking like a sketch drawing process. You can use robotics, you're thinking robotic and human collaborative process. The tools will change your thinking methodology. I think that could not be separate. What is the first? So the tools is a kind of culture. It's kind of thinking, design thinking, building in your body.
Great. That's my one last question, right?
I was wondering, what's your thought? What is your thoughts of what happened with Ron Chomp that Corbusier did in 1950, which is made, as I understand, designed and composed strictly with pencil and paper, with none of, obviously, any of the technology even close to what it is today. That was a future of architecture also that didn't really continue and all. And so I was just wondering, how does that relate anything to it, where it's really feelings and tone and reasoning of what the building was about and for who, the people and the religion, of course, and where he didn't have any technology to it all came out of, and you know, there's so many other examples, you know, Hans Sharon to, of course, Mr. Wright, you know, and all those other sort of guys.
I think
What's that architecture about that?
if I understand what your question, I think not every day we make a revolution. Le Corbusier, I think he's standing at this, just the moment, put forward a new paradigm, because that is a paradigm of the thinking methodologies. That's a revolution time. But I think right now is another revolution time, because the modernism gave us this kind of autonomous process for the form making is totally different to the classical buildings, because that is totally based on new ethics and a new understanding of the logic of the buildings that could be constructed based on certain kind of structure system, certain kind of new materials. You can imagine the social production system is totally changed after the World War. It's all because of the new technology at that time was happening. So Le Corbusier is someone who gave us a theory and gives us the practice and showing something important to us. But right now we can think about another revolution is about the information age, the exchange of the information, the change of the tools. The intelligent tools can build us, can make us even more stronger. And the customized process, the prefab process, totally different to the World War after the World War II, because the World War II, the industry process is kind of all the components are the same in the prefab industry, but right now we can use robotics to make all the components different, but it could be same efficient. That means the machine age right now is integrated with the information age. That is another turning point where I think about, we need to rethink about why we make design, how we make design, and what's the direction of our industry we're going. So I think, if I understand your question, I think although the great master, they are great because of the time, not because of themselves, because they're standing at the right time, put for the right thing, doing the right thing. But right now, if we understand what's happening surround us, not just in architecture discipline, we should be rethinking on what we should teach, what we should learn in our pedagogy system and in our practice process.
Great. Thank you very much for unpacking.